1, 2, 3, 4, 5, 6, 7. Oh, it was easy for me to count how many stars or arrows are there in this picture. But it was not that easy to count them here. Because there is a chaos here. But here things are classified according to their shapes. So it is easy to know which is an arrow, which is a star, which is a circle, and so on. The same thing had happened in 18th century. There were many elements that scientists knew about, but they were never classified. So there was a need of classification of elements so that scientists could know which elements show similar properties. Now, in the beginning, attempts were made by chemists to classify elements on the basis of factors such as density, malleability, ductility, and also to consider whether they are metals or non-metals. So basically, initially, elements were classified based on their physical properties. But none of these early classifications proved to be satisfactory because the number of elements falling in a particular group were so large that it did not serve the purpose of generalization. And some of the characteristics being considered varied under different conditions. Like certain metals cannot conduct electricity at normal temperature or normal conditions, but they can conduct electricity under different conditions. So these were some ambiguities. And there were certain elements that showed metallic as well as non-metallic characteristics. So all these reasons did not lead to a satisfactory classification of elements. Then obviously scientists were in search of characteristics of an element that would never change, so that according to that characteristics they can classify the elements. So there was a scientist, William Prout, who discovered that atomic mass of an element never differs. Throughout it is the same. So he considered this as a very important characteristic, and he said that this characteristic could therefore form a truly scientific basis for a satisfactory scheme of classification. In this race, the first one to classify elements was Johann Dobereiner. Johann Dobereiner studied as a pharmacist in Germany at Munchburg, and then he studied chemistry at Strassburg. After some years, he became the professor of chemistry and pharmacy in the University of Jena. He was the first one to find out that platinum can be used as a catalyst. And he also was the first one to classify elements and found out similar triads of elements that led to the development of the periodic table. Let us see how Johann Dobereiner classified elements. He knew that every element is made up of similar kind of particles. These particles are called atoms. Every atom is made up of a center positive charge called nucleus. In this nucleus, there are two kinds of particles, protons and neutrons. Protons are positive and neutrons are neutral. Electrons are present around the nucleus in orbits, and electrons are negatively charged. In an atom, the number of protons are always equal to the number of electrons. Every element has atomic mass and atomic number. Atomic mass is nothing but the total number of protons and neutrons present in the atom of the element, and atomic number is the number of protons. But because number of protons and number of electrons are always equal in an atom, atomic number can also be represented as number of electrons. He started classifying elements in the increasing order of their atomic masses. He found out that a group of 3 elements can be obtained having similar chemical properties. He also observed that in each group of 3 elements, the middle element's atomic mass is always equal to the arithmetic mean of the atomic mass of the other 2 elements. Confused? Let me give you one example. He considered the first group which had lithium, sodium and potassium. He found out that these elements are alkali metals. Alkali metals as in the metals which react with water and form alkalis, that is the basis. Okay, in this group we have lithium, sodium and potassium, where lithium and potassium are the first and the third element and the middle element is sodium. Sodium's atomic mass is 23, lithium's atomic mass is 7, and potassium's atomic mass is 39. So when we take the arithmetic mean of atomic masses of lithium and potassium, we get 7 plus 39 upon 2, which is nothing but 46 upon 2, which is nothing but 23. That is the atomic mass of sodium. So what Dobereiner said was correct, that the atomic mass of the middle element is always equal to the arithmetic mean of the atomic masses of the other two elements. Another group made by Dobereiner had calcium, strontium and barium. This group of metals are called the alkaline earth metals. Alkaline earth metal means the metals whose oxides are alkaline in nature and they are found in earth. So calcium, strontium, barium are alkaline earth metals. Okay, calcium's atomic mass is 40, strontium's atomic mass is 88 and barium's atomic mass is 137. So let's take the arithmetic mean of calcium and barium's atomic masses. We get 40 plus 137 upon 2, which is equal to 88.5. That is approximately equal to the atomic mass of strontium. So again, this is a Dobereiner's triad. The other group is known as the halogen group formed by Dobereiner. This group has elements chlorine, bromine and iodine. These are called halogens because they react with metals to form salts, halide salts, which are usually found in the sea. Now, let's talk about the atomic masses of all three of them. Chlorine's atomic mass is 35.5. Bromine's atomic mass is 80 and iodine's atomic mass is 127. So let's take the arithmetic mean of chlorine and iodine's atomic masses. We get 35.5 plus 127 upon 2, which is equal to 81.5, which is approximately equal to the atomic mass of bromine. Again, this is a Dobereiner's triad. This is such a smart concept that Dobereiner found out. But there was a limitation. He could only find out 3 triads from the elements known at that time. Then came John Newlands. He was an English scientist.